All right, welcome back, everyone. If you've not watched part one of the 13-6 video yet, you need to do that before you jump into this one because this is part two. This is a continuation of what I talked about in part one. And what we're doing is we're looking at graphing lines, graphing linear equations. And we've done one example where we took an equation that was in standard form because it was something times x. It fit that form of ax plus by equals c. Something times x plus something times y equaled a number. And that's where, you can look at the 3x plus 4y equals 12 and hopefully see how it kind of matches this form. So it's called standard form. And we did that by just plotting points. We actually used the x and y intercepts. First we found the y-intercept, right? That would be this point right there. That is my y-intercept because it's the point where my line is crossing my y-axis. I found that by putting a 0 in for x and then solving the remaining equation for y. So I put a 0 in right there, and that left me an equation that said 4y equals 12. So that told me that the y value would be 3 that goes with an x value of 0. So 0 comma 3 was one of my points. Then I found the x-intercept, which was 4 comma 0. And again, the way I found the x-intercept is I put 0 in for y, which got rid of the 4y part, and it turned it into 3x equals 12. I solved that pretty easily and got x equals 4. So 4 for an x and 0 for a y. That was also a point on my line. And then just to make sure I hadn't made any mistakes, I found a third point, and just to see if it lined up with the other two, and it did. So I connected them all, and there's my line. Now that's one way to graph a line, just by plotting points, plotting the x-intercept and the y-intercept, or plotting any other points that you can figure out would be solutions to the equation that you're given. But if you remember back in section 13-2, we learned, when we were talking about slope, we learned that it's pretty easy to graph a line if you know the slope of the line and one point on the line, right? If you can start at a point and then use rise over run from the slope, you could put another one, right? So for instance, if I knew that this point right here was on the line I'm supposed to graph, and I knew that it had a slope of 3 over 2, then I could go from this point, I could go up 3 or a rise of 3 and over 2 or a run of 2, right? I could make a jump of 3 up and 2 over, 3 up and 2 over, and put another point. Then I could do it again, 3 up and 2 over and put another point, 3 up and 2 over and put another point. And all of these, since I'm making the same rise over run each time, those would all be in a nice straight line, and I could graph that. I could graph that line that's described by that slope and that point. So that idea we've kind of already covered, this idea that using slope and a point on the line makes it pretty easy to graph the line. That takes us into slope-intercept form. So it's another form, another way you can write a linear equation. This was standard form, ax plus by equals c. Now we're going to look at slope-intercept form. So the way slope-intercept form looks, and it's going to sound really familiar hopefully, it's y equals mx plus b. So m and b are really the important points. The y and the x are just our variables in this equation, right? Every linear equation is probably going to have x and y both, maybe sometimes just x, maybe sometimes just y, but for most of them it'll have an x and a y in it. So that's where the x and the y are here. The m and the b are the important points, are the important numbers in this equation. M represents the slope of the line, and b represents the y-intercept, or the place on the y-axis where that line is going to cross. So why am I how is this connected to what we just talked about? Because this is a point and this is the slope, right? So if you have an equation that's in the form y equals mx plus b, you have all the things you need to pretty easily graph it. You don't have to bother with trying to find ordered pairs that are solutions to the line or to the equation. You don't have to make any kind of chart. You don't have to do a lot of algebra really. If you have it in this form of y equals mx plus b, you can just look at a couple parts of that equation. You can start with a point, you can use the slope to find more points, and then you can connect them to draw your line. So let's look at a couple examples real quick. In example 2, we have this line y equals 2/5 x minus 9. Now, one of the things you can see right away is if I was trying to solve this by plotting points, by trying to pick pairs of x's and y's that would make this thing equal, that fraction is going to make that pretty hard. It's going to be kind of tricky to try and pick out points that I can put in for x that I would then be able to easily solve an equation for to get y values that go with what I picked out for x. It's going to be kind of a pain. But I notice that this is in y equals something times x plus something form. Yes, it has a minus sign right here, but remember, minus 9 is the same as plus negative 9, right? So this is y equals something times x plus something. And those two somethings are what's going to allow us to graph this pretty easily. So follow along, I'll show you what we're going to do. Hopefully this sounds pretty familiar back from Algebra 1. So the first thing I need to do is find the point where I'm going to start. I need to find the first dot that I can put on my graph. And the place I'm going to look for that is at B. Remember, B is my y-intercept. So in this equation right here, the value of B is negative 9 because it originally said minus 9, but like we just said, that means plus negative 9. So this has a B value of negative 9. That means that if I go to negative 9 on the y-axis, I can put a point right there because that is the y-intercept of my line, of my equation. So there's my starting point. Now my slope is 2 over 5. That means that from my point that I already graphed, if I go up 2 and right 5, I'll have another point. Up 2 and right 5. If I do it again, I'll have another point, so up 2 and right 5. Those 3 points, if I connect them, that's my line that I'm graphing. So I'm going to connect those with as straight a line as I can draw, and there I have it. There's my line. See how easy that was? I just started at the value of b on the y-axis, so I went down to negative 9. I used my slope as rise over run to find a couple more points, connected them, there's my line. All right? Now, where it can be a little bit trickier is if I look at this. Now, this is actually in standard form, right? This is in the ax plus by equals c form. 1x plus negative 2y equals 8. But I can do a little bit of algebra, rearrange this, get the y by itself, and then I'll be in business, right? So I'm going to rewrite my equation. And now I want to turn this into, eventually I want to have it say y equals something times x plus something. And so what that means is I need to isolate this y. Get this y right here all by itself. First thing I'll do is I'll subtract x from both sides. Now the x is gone here, the negative sign and the minus sign is not. It turns into a negative sign on 2y. So I have negative 2y equals, now I can't combine 8 minus x. And I could write it as 8 minus x, but if I notice where I'm trying to get to eventually, I want that x in front. So I'm going to put that x in front right there as a negative x plus an 8. Hopefully you see that that means the same thing as 8 minus x, which is what this says right here. I'm just writing it as negative x plus 8. Now I almost have y by itself. I just need to get rid of this number that's in front of it. So I'm going to divide by negative 2. If I divide by negative 2 on the left side of the equation, I have to divide everything on the right side by negative 2 as well. So I'm going to divide that by negative 2. And I'm also going to divide the 8 by negative 2. So where does that take me now? Well, the y is now by itself because those negative 2's are going to cancel. So I have y equals, then I have this weird looking negative x divided by negative 2. I want to write that as something times x. So what is negative x over negative 2? What does that translate into in terms of something times x? Well, first of all, I notice I have a negative on the top and bottom. So the rules of math tell me that those will kind of cancel out and just both become positive. So now I have x over 2. Well, x over 2, that's like 1x over 2. And 1x over 2 would be the same thing as 1 over 2 times x over 1, right? 1 over 2 times x over 2 would give me 1x over 2 times 1, or just x over 2. So that tells me that this number that's in front of my x, it looks like negative x over negative 2 right in this step. I'm going to write that as 1/2 x. So I have y equals 1/2 x plus what? Well, What's positive 8 divided by negative 2? It's negative 4. So now this looks a little bit weird, so let's rewrite it. Y equals 1/2 x plus negative 4. I'll just write that as minus 4. So now this is just a rearranged version of x minus 2y equals 8. Y equals 1/2 x minus 4. But now I can graph this really easily. I can see that my b value is negative 4. I can see that the slope is 1/2. So if I go to negative 4 on my y-axis, I can start with a point there. I can use my slope of 1/2 to go 1 up and 2 over. 1 up, 2 over, 1 up, 2 over, 1 up, 2 over. Of course, I could also go -1, -2, meaning 1 down and 2 left, right? 1 down, 2 left, 1 down, 2 left. All of those points should now be in a nice straight line for me. If I connect them all, that's my line. Again, doing the best I can drawing a straight line here. There's my line that I was supposed to draw. So I took that standard form equation, I rearranged it, got the y by itself, thought about what's in front of the x, or what is the x being multiplied by, because that's my slope, and then what is being added or subtracted from that term with the x, because whatever's being added to that, that's my y-intercept. Okay, folks, oops, let me close that notification. That's about all the time I have for now. It looks like my battery's about to die anyway. So good luck taking a look at these homework problems, and we'll see you next time.